Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're looking at an introduction to organic chemistry. And there's something that's very important that you carry into the exam with you, and that is a table, which is the basis of all chemistry, including organic chemistry. What is the name of that table? I'll give you a hint. This is what it looks like. Do you recognize what that is? It is the periodic table of the elements. The periodic table of the elements. And we have our element hydrogen here, then beryllium, boron, and then we have carbon, nitrogen, oxygen, fluorine, and helium. Right, so there's some of the elements of the periodic table of the elements. But the most important thing about this table, most people who carry it into the exams don't seem to grasp the most important thing about this table. And that is that all elements in these columns, which are called groups, you have group 1, 2, 3, 4, 5, 6, 7, and group 0. In group 1, all the elements in this group, we can imagine them as having one hook, meaning they form one bond. And all elements in this group 2 have two hooks. We can imagine them forming two bonds. And all elements in group 3 have three hooks. And we can imagine them forming three bonds. And all elements in group 4 have four hooks, and we can imagine them forming four bonds. So how many hooks do you think those in group 5 have? No, three hooks. So it goes 1, 2, 3, 4, 3 hooks in group 5, 2 hooks in group 6, 1 hook in group 7, and no hooks in group 0. So that is perhaps the most important thing you need to know about the periodic table. Each group 1, 1 hook, or in scientific terms, a valency of 1, in group 2, valency of 2, 2 hooks, 3 hooks, 4 hooks, 3 hooks, 2 hooks, 1 hook, and 0 hooks. And the simple rule is you can take any element and combine it with any other elements, but as long as you hook up all the hooks. So let's give you an example. Now, of the elements in the periodic table, certain of these are going to play a very important role in organic chemistry, and perhaps the most important of all is carbon. Oxygen would be important, and hydrogen. So those are the three we're going to focus on. So let's just show you, for example, how two hydrogens, each with one hook, could combine. You see that? One hydrogen with one hook, another hydrogen with another hook, and it forms the gas H2. And you see how it's satisfied all the hooks. Or what about oxygen? Oxygen with two hooks may combine with another oxygen with two hooks, and we get the gas O2. And again, all the hooks have to be hooked up. We could get nitrogen, which has got three hooks, hook it up like that into gas nitrogen, 80% of the atmosphere. Now, why is carbon so important? Well, carbon's important because it's the element in the group with the most hooks. So, for example, carbon, having its four hooks like this, could, for example, link up with another carbon, and it could link up with another carbon. And can you think of any reason why it couldn't hook up with some more carbons? So that is the reason why carbon is having the most number of hooks in group 4, valency of 4, is able to form super long chains of carbon. And then it's got interesting things that must fill up these other hooks. For example, the most common thing would be hydrogen filling those additional hooks. But as long as all the hooks are filled up, we have not broken any laws, and all the elements are satisfied. So if we look at, for example, this organic compound, organic because it it consists mostly of carbon, long chains of carbon, with hydrogen. In this case, there's no oxygen. So this would be a hydrocarbon with 3 carbons and quite a lot of hydrogens. We'll study that in a moment. But it's satisfied because each hydrogen's got its 1 hook linked up, and each carbon has got its 4 hooks linked up. And therefore, as long as we choose an element with another element and we make sure all the hooks are linked up, then the elements are satisfied. So that is the most important thing that we need to know about the periodic table. So here we have our groups, here we have our periods, and the hooks increase to 7, they go 1, 2, 3, 4 hooks, valency of 4, 3, 2, 1, naught, and then it repeats again 1, 2, 3, 4, 3, 2, 1, naught, then it repeats again 1, 2, 3, 4, 3, 2, 1, naught, and this is our basic periodic table with just the first couple of elements involved.